Today we're taking a look at the negative exponent theorem. So what happens when we have a power expression with a base raised to a negative exponent? Well, it simply says for any non-zero base b and an integer exponent n, b to the negative n can be rewritten as 1 over b to the positive n. So in words, what that means is you're going to take the reciprocal of the base b and raise it to the positive power n. Let's apply the negative exponent theorem and rewrite some of the following expressions. So x to the negative 2 is really 1 over x to the positive 2, or 1 over x squared. All right, 3 times x to the negative 5th power. That negative 5 is only attached to the base of x. So be careful here. This is really going to be 3 times 1 over x to the positive 5th power. Now when we multiply these together, remember you multiply straight across, this will be 3 in the numerator over x to the 5th. All right, our next example C is very similar to the previous one. We have x times y to the negative 3. That negative 3 is only being applied to the y, so I'm going to rewrite this as x times 1 over y to the positive 3 power. When I combine these, again, I'm going to multiply straight across. I get x being divided by y to the 3rd power. All right, our next example, D, now is different from the previous two. This negative 3 needs to go to both of these bases. In other words, it's going to be x to the negative 3 times y to the negative 3. So both bases now are going to take the reciprocal of and raise those to the positive powers. So this becomes y over x cubed times y cubed. All right, 3 to the negative 4 can be rewritten as 1 over 3 because that is the reciprocal of 3 to the positive 4th power. Now let's simplify this further. 3 to the 4th power is 81, so that is 1 over 81. Next, we have 7 to the negative 3, very similar. I'm going to take the reciprocal of my base, which is 1 over 7, and raise that to the 3rd power. And so this becomes 1 over 343 is what the equivalent of 7 cubed is. All right, example G here just says, write the following as a fraction, 10 to the negative 3rd. Then write it as a decimal. Is this value positive or negative? So first of all, 10 to the negative 3rd, I'm going to take the reciprocal of my base. That becomes 1 over 10 to the positive 3 power, which means that's 10 times 10 times 10, or 1,000. And now I also recognize that 1 over 1,000, written as a decimal, is 0.001. And finally it says, is this value positive or negative? Now the temptation here is to say this is a value that's negative because this negative exponent. Well, be careful of that. You're actually not going to look at the exponent to determine the value. It's rather that base. Now, the base, if it's positive, your result could be positive, but if it's negative, it could also be positive, and there's a little bit of discussion that goes along with that. But for right now, just know that that negative exponent only causes you to take the reciprocal of the base, and it does not change the value or make the value positive or negative. All right, let's look at a few more examples here. Example 3 says the intensity of a sound S is inversely proportional to the square of the distance the person is from the sound. So this goes back to our first chapter that we studied this year. This is an inverse variation equation. We're going to write that inverse variation equation that goes like this. The intensity of the sound varies inversely with the square of the distance the person is from that sound. Now we want to rewrite this equation with no denominators. In other words, I got to get this d out of that denominator. Well, the way we do that is we're going to use negative exponents. So this is really written as s equals k, our constant of variation, times d to the negative 2 power. So here are two equivalent formulas for the intensity of sound, one written with the distance squared as the denominator, the other one just written as a product of k times d to the negative 2nd power. All right, let's see if we can rewrite the following again with no denominators, just following the previous example. So this can be rewritten as d equals k times w to the negative 1st power. So what we're doing is we're pulling that variable out of the denominator and writing it with that negative exponent instead. Our next here is n is equal to k times d to the negative third power, and now we have x times 5, or sorry, x to the fifth times x to the negative 8. So again, if we wanted to combine these, what that would give us would be x to the negative third, because when we have the same bases, we're multiplying. Remember that we're going to add our exponents. So here is x to the negative third. All right, that's example 4. Let's take a look at example 5 and see how we can use some of our properties of powers and negative exponents in combination with each other. We want to rewrite this one as a fraction here. So we have this product that's being raised to the power. So remember that power needs to go to both of those bases. So this becomes 5 cubed b cubed times, and now here we have 4 that's being raised to the negative fifth. So that's 4 to the negative fifth, b to the negative fifth. Now remember, we're going to take the reciprocal of these. So let's start by simplifying these first two terms here. 5 to the third power is 125 b cubed, all divided by, now this 4 is going to come down here to our denominator. So that will be 4 to the positive fifth power times b to the positive fifth power. All right, now let's simplify. We have 4 to the fifth, and that can be simplified to 1024. So we have 125b cubed all over 1024b to the fifth. So there we have it. If we want to simplify this a little bit further, we have b to the third on top, we have b to the fifth on the bottom. That can be rewritten as 125 b to the 3 minus fifth all over 1024. And then we're going to subtract the 3 and the 5. That gives us 125 b to the negative 2 all over 1024. Now, we don't want any negative exponents here, so that b to the negative 2 means that it needs to come back down here to the denominator. So our final solution here is 125 over 1024b squared. All right, let's rewrite this next one here as a fraction as well. So again, we're going to apply our power of a product to this first term here. We have negative 3 to that 2, so I'm going to rewrite that as 2 to the negative 3. And then c, and this is a power of powers, so I'm going to multiply those to the negative 6. All right, now our next product here, we just have 3c to the fourth. There's no power outside that parentheses. Okay, so let's start to simplify this. This becomes 1 over 2 cubed, and then c to the positive 6 times 3c to the fourth. Now again, anything can be written as a fraction over 1, and we're going to do this so that we can simplify these. We're going to multiply straight across. We have 3c to the fourth in our numerator. 2 cubed is going to simplify to 8, and this is c to the 6. All right, now in the end here, I have c to the fourth on top, c to the 6 on the bottom, so that really means I'm going to have a remaining c squared in the denominator. All right, so there we have it simplified to a fraction using our power properties and our negative exponent theorem. All right, examples 6 and 7, go ahead and pause the video and see if you can arrive at the answer on your own.